hypothesis. So here's an image of Quine. Willard Van Orman Quine is arguably the most important and influential analytic philosopher in the 20th century. Hugely influential, particularly in the latter half of the 20th century. Before then we had, Russell, Wittgenstein, Carnap, logical positivism, and then when Quine comes along, bad things happen to what had been passing for analytic philosophy, particularly belief in this long-held distinction between analytic statements and synthetic statements, and among other things. So you can see the dates at which he lived. I met Quine the year before he died because, as you know, I got my PhD from Washington University in St. Louis, and the chair of the department was one of the best-known Quine scholars at the time. Joe Ullian, the co-author here, was at Washington University. When I was a graduate student, and one of the things you do as a graduate student is you end up becoming a teaching assistant. So I was a teaching assistant for Joe Ullian's Philosophy of Science course. This was my edition of the book that we used. So the book that you have is just a newer edition of this book, so I really liked the edition. And Ullian was a Quine scholar, so there's a whole lot of Quine stuff going on at Washington University, including a conference on perspectives on Quine, where they bring in Donald Davidson, all these big names and so on. So you get a lot of Quine when you're at WashU. And I like Quine quite a bit. So he's an American, speaks multiple languages, taught at Harvard, knows everybody who's anybody in analytic philosophy in the 20th century that was alive. So analytic philosopher, logician, he attacked the analytic-synthetic distinction, known for that in Two Dogmas of Empiricism, which is one of the most probably, it's always listed as one of the top 3 most important pieces in analytic philosophy in the 20th century. But he also writes on, very famously, the indeterminacy of translation, which we would cover in, say, a philosophy of language class. Defender of naturalism and holism, and he's known for this Web of Belief, which is the title of the book from which our selection comes from today. Again, I know Two Dogmas of Empiricism and when it was published, so pretty much the latter half of the 20th century, was Quine. He's a prolific writer. Wrote lots and lots and lots of essays, many of which were anthologized. So, boy, there's a lot of stuff you could explore through the writings of Quine. And many of his works are quite accessible, and he writes beautifully in the same way that Russell does. I mean, these are really good writers. I really like reading Quine. So this is Quine. The other person, I couldn't find a very good image of Joe. He's a character too. He's emeritus now from Washington University. He's still alive, but I couldn't find when he was born. American. He got his PhD from Harvard under Quine. He's an analytic philosopher like Quine, a logician like Quine, and he ends up writing a lot on both analytic philosophy and logic, and also a lot on Quine himself. So there are people who make their careers out of, other people's careers. We all can't be Quines. But Joe's a very bright guy. Like I said, he was at Washington University when I was there. In fact, I was chairing a session at the APA conference. I guess that was in the spring. Yeah, when I was teaching philosophy of language. And Joe was supposed to be chairing the session just after mine, but he ended up having to get someone else to do it for him. I was looking forward to seeing him. One of the things I liked about him, he's a character. He was bi-coastal. I don't know how he came into his money, but he had money. So he had a house in California, I think in San Jose. He had a house in Massachusetts, outside Boston, and a house in St. Louis. So Joe would always spend part of the week in this part of the country, and then part of the week in this part of the country, and only teach like on Tuesdays and Thursdays. So he'd only be in St. Louis for like Tuesday through Thursday, and then he's gone. Rabid college basketball fan, just going all over the country, He's an interesting guy. I enjoyed being his TA for that class. So I only put the one book here that he co-authored with Quine. So this is Joe Ullian. All right, so let's turn our attention, let me get out of this, to the presentation, which is here. So Molly, let me turn it over to you.
Right. Okay, so this is the piece written by Quine and Ullian.
Speak up just a little.
Hypothesis. So what they're trying to do in here is explain the different methods, or I guess theoretical framework that you can design a hypothesis, and it should meet these criteria. So he goes through the 5 virtues of framing a hypothesis. So the first one is.
Oh, we got to say something before we get there.
Okay.
He says,
What are we going to say?
in the paragraph that begins with "it is now recognized," he says, "it is now recognized that deduction from self-evident truths and observation is not the sole avenue to truth, nor even reasonable belief." Remember, if you know anything about the history of Western philosophy, modern philosophy begins with René Descartes, the father of modern philosophy, right? And it begins in doubt and skepticism about the limits of our knowledge and what we know, because many of the things that we had taken on authority for tradition to be true and things that we knew turned out to be things about which we were mistaken. So Descartes is a rationalist, and all rationalists believe in the primacy of deductive reasoning, and not just deductive reasoning, but the belief in the notion that from certain self-evident propositions we can deduce things from it. And if we can deduce something from something that's true, then what we deduce from it must be true, given the way deduction works, such that we can have demonstrable certitude about the things that we claim to know. And Descartes, at the very beginning of modern philosophy, discovers, he thinks, this one thing that's impossible to doubt, and from that he deduces certain other things. He assumes certain other things too, but from this, I think, therefore I am, there must be something that exists, otherwise you wouldn't be able to be deceived or whatever. And he ends up claiming that he is essentially a thinking thing, not a material thing, not a corporeal thing, because he can deny that he's got a body, but he can't deny that he has a mind, right? And then because God exists and God wouldn't create him such that he's always being deceived in his ideas, that many of the ideas that he has are ideas that correspond to things in the world. But rationalists all believe in the notion that there are these innate ideas, that there are these certain self-evident propositions from which we can deduce other things. Science doesn't proceed that way, right? There are periods in history, Western civilization where we tried to deduce things axiomatically from certain truths, but science proceeds by observation. So this paragraph continues. He says, a dominant further factor in solid science, as in daily life, is hypothesis. In a word, hypothesis is guesswork, but it can be enlightened guesswork. So when we're talking about hypothesis generation in science, this is consistent with our saying that it's hypothesis testing, which is really the hallmark of science. So what they're talking about here is how is it that we come not merely to frame hypotheses, because that's sort of a psychological exercise. How we discover hypotheses isn't something that's traditionally held to any sort of normative standards, right? Because you can discover a hypothesis in a dream or in some drug-induced state or whatever. What matters is that you test it. I mean, that's the key to doing science. It's testability, and as Popper said, refutability and whatnot. So they do give us these virtues, he says, but these aren't necessary and sufficient conditions, these virtues that they identify. It's a sort of a set of virtues, and we tend to privilege the hypothesis that exhibits as many of these as possible. No hypothesis can exhibit all of them because some of them are mutually exclusive. So he says, hypothesis where successful is a two-way street, extending back to explain the past and forward to predict the future. So what we try to do in framing hypothesis is to explain some otherwise unexplained happenings by inventing a plausible story, a plausible description, or a history of relevant portions of the world. What counts in favor of a hypothesis is a question not to be lightly answered. We may note 5 virtues that a hypothesis may enjoy in varying degrees. Now, it's not going to enjoy them all, right? And the first of these is what? All right, so what's conservatism?
So it's recognizing that your past beliefs exist, and either being able to ignore them in the face of, well, not ignore them, but, like the Zers knows, when something happens that cannot be reconciled within our prior beliefs. So you have to be able to accept new beliefs, basically, or rely on your past beliefs to determine the most likely outcome of the situation. So the example I gave was the magic trick was performed. So there are a lot of possibilities. It could be real magic, it could be luck, but conservatism would lead us to believe that sleight of hand is.
So what would be the hypothesis in case of conservatism?
I guess it would be,
All right, so you're watching a magic trick. In fact, I just saw a trailer for some David Blaine thing with some celebrities, and celebrities are, oh man, that's real, they're freaking out. So the hypothesis would be that it's not magic, right? That it's an illusion, that it's whatever.
Yeah, it's sleight of hand.
And how is that conservative?
Because it's more rational, it's more.
That doesn't make it conservative. What makes it conservative? What's the key to conservatism?
It doesn't require us to abandon our belief that magic is false.
Or true.
That is, a conservative hypothesis is one that doesn't require that we eliminate a lot of stuff that we accepted to be true prior to that. I think they say that the less rejection of prior beliefs required, the more plausible the hypothesis, all things being equal, right? So the virtue of conservatism has to do with its consistency with the stuff that we had already accepted to be the case. So a hypothesis that isn't conservative would be one that would require that we abandon a lot of what we accepted to be the case before that. So all things being equal, it's better for a hypothesis to conserve a lot of what we thought we knew to be the case rather than to require the wholesale abandonment of our ontological commitments to things or our understanding of how things work. Does that make sense? So that's what conservatism is. I like the quote here. It says, perhaps, it's talking about like a magician or whatever, he says, perhaps he resorted to telepathy or clairvoyance, but this would wreak havoc on our web of belief. And that's the first time we're seeing that there. So Quine is known for a defender of a thesis called the Quine-Duhem thesis, which has to do with holism. And that at the beginning of the 20th century, say, Russell's time, people thought that the smallest unit of that something could be in order to be true would be a statement, and that we can confirm or falsify our statements one by one. But as Quine defends in the Two Dogmas of Empiricism, is that anything can be held true come what may if we make drastic enough changes elsewhere in our system, such that we could discover something or have an experience that would show us that, for instance, 1 + 1 doesn't equal 2, right? Like you get one piece of mercury, another piece of mercury, you put them together, you got one piece of mercury, right? Historically, we tend not to count that as a counterexample against the truth of 1 + 1 being equal to 2 because that's supposed to be an analytic truth, a necessary truth. But part of what happens as a result of Two Dogmas of Empiricism is the abandonment of this distinction between analytic truths and synthetic truths, which means that anything can be falsified. Any statement, even the privileged statements of logic and mathematics, at the core, at the center of our web of belief, they can be revised as well. But revising the truth values of these core truths of logic and mathematics would create drastic ripples elsewhere in our web of belief. So we can alter their truth value. We can revise them in the face of experience. We just tend not to do that because doing so would create drastic ripples elsewhere in the web of belief. Yeah.
Yeah, he also talks about revision still being possible even if we adopt conservatism, when he says that the truth may indeed be radically remote from our present system of beliefs. And he says that instead of just taking a leap in the dark, which would be assuming magic is the case,
Right.
he says that over time we take a series of gradual steps. So like if we see enough repeat performances where sleight of hand is ruled out, we might have to say no.
I think that's fair. Again, this hypothesis is guesswork, but it can be enlightened guesswork. So one virtue is conservatism. But there are going to be occasions when the hypothesis that we ought to prefer would be the one that requires that we do abandon a lot of what we had accepted to be the case, because there isn't anything that we now believe or claim to be true or claim to know that we can't discover we're mistaken about. And that's the important bit here. So nothing is immune from revision. Nothing. Not even the fundamental truths of logic and mathematics at the core of a web of belief. Now think about it. Those of you who've had logic with me know that validity is an important concept, right? And here's my most hackneyed example of a valid argument form. If P then Q, P therefore Q. What's the name of this argument form? This is modus ponens, right? So anytime you have a conditional and you have the antecedent of that conditional, you can deduce the consequent of that conditional, because it's impossible for these premises to be true and for this to be false, right? This is a valid argument form. But to say that it's valid is to say that it's impossible for the premises to be true and for the claim to be false. Is there anything that prevents us from defining validity another way? And the answer is no. If I were to, in fact, think of another argument like all humans are mortal, all humans are mortal, all basketball players are humans, therefore I need to write it out. All M is P. All S is M. Therefore, all S is P. This is an argument form that's also a valid argument form. It has a name. It's called Barbara. This is an AAA1 argument form in classical logic. Can you give me some terms for the minor term, the major term, and the middle term where the resulting argument is cogent? Doesn't matter what terms you plug in. Not all of them will be cogent, right? So if I say S is kittens or S is snakes, P is peacocks, and M is meerkats, all meerkats are peacocks, all snakes are meerkats, therefore all snakes are peacocks. Well, that doesn't make any sense, right? So can you give me a substitution instance where each of the premises is true?
M is humans.
All right.
P is mortal, or P is are mortal, or is mortal.
Mortals.
Yeah.
And
S is basketball players.
basketball player? Sounds awfully familiar.
Yeah.
doesn't it? SK, basketball players, P-L-A-Y-E-R-S. Bear with me. If we use these terms for the minor term, the major term, the middle term, we end up with all humans are mortal, all basketball players are human, therefore all basketball players are mortal. Right, that works. Now the thing is, if you were to symbolize this argument form in the language of sentential logic, you would have to do it this way. P, Q, R. Because we have no symbols in predicate logic that take the place of quantifiers. We have no symbols that take the place of terms. But this is a valid argument form. Does that mean that validity depends on the system that we're using?
Because PQR is not necessarily valid.
This is not a valid argument form. And I can show that pretty easily, because if you can come up with a substitution instance where the premises are true and the conclusion is false, then it's invalid. P, Sophie is a cat. Q, the moon is not made of green cheese. R, Rob is wearing a blue shirt. I mean, clearly that's invalid, right? That doesn't follow from that evidence. So here's the thing. Have I revised the notion of validity in relation to these two different systems? In sentential logic, this is a valid argument form. In classical logic, this is a valid argument form. Does that mean the notion of validity is changing from system to system? And the answer is no. There's an incompleteness. In fact, think of Gödel's theorem, that in any axiomatic system, any formal system, there are always going to be some truths that can't be proven to be true within that system, due either to limitations of the language, which is the case in sentential logic, because we have no symbols for quantifiers and terms in sentential logic, so we can't reveal the full logical structure of this argument. We can't express this argument form in the language of classical logic. So here's the point. It's not the case, really, strictly speaking, that an argument that's valid in one system will be invalid in another. It's that rather the language of one logic may be inadequate for us to reveal the logical structure we need in order to capture its validity. So validity doesn't change from system to system. My point is, if we change our notion of validity, and we can do that, this would create drastic ripples in all of our formal axiomatic systems. It's not that we can't do it. There's nothing to prevent us from changing the definition of validity to something else that may not be as useful, or to discover that there are occasions when something as fundamental as 1 + 1 doesn't equal 2. But this is evidence for the notion that every statement's revisable. As part of the argument, there is no fundamental cleavage between analytic statements and synthetic statements, between necessary statements and contingent statements. So all of this gets put in a larger framework in terms of our knowledge, which he refers to, as the title of the book suggests, the web of belief. that another quote from the two dogmas is that any statement can be held true come what may if we make drastic enough changes elsewhere in our system. That is, we can always preserve the truth of something by making tweaks and adjusting the truth values someplace else. And we can adjust the truth value of things in the core of our web of belief as well, but we tend not to do that out of conservatism because we don't want to create these drastic ripples, but we can. Yes?
It's probably not his language that he would use, but would you say that something or a web of belief then is just composed of synthetic, something like synthetic claims or synthetic beliefs?
But
that's not his language, but basically he's saying that there is no analyticity where necessity comes into play. So everything is, in a sense, synthetic, but it's not synthetic. I don't know what to call it, but it's not necessary. It's not analytic, right? Every belief, no belief is analytic or necessary.
That's closer to the mark, right? That's not really consistent with the vocabulary,
Yeah.
but the idea is, we're just looking at modus ponens. You can write any valid argument in the form of a conditional statement. In fact, we just did this in my last class. Whereas we traditionally write arguments this way in standard form. If P, then Q, P, therefore Q. I can write this argument in the form of a conditional statement, where the antecedent will be the conjunction of the premises and the consequent will be the conclusion. So P, then Q, dot P, therefore Q. Is this argument expressed in the form of a conditional statement? You with me? If I can show that this statement form is a logical truth, I've indirectly proven the validity of this argument, because every valid argument, when expressed in a conditional statement, will be a logical truth. If I use a truth table to prove that this is a logical truth, and I can do that right now, it's a tautology. If I use a proof to prove that this is logically true, well, I end up making this a theorem. The point is, we can change, for instance, the truth conditions of conditionals such that this isn't necessarily true. So what you have to accept when you accept the notion that there really isn't this fundamental cleavage between analytic truths and synthetic truths is that this is, if it's analytically true, true only in relation to how we define validity and the truth conditions in our formal logics. We can change those. There's nothing that says, well, that's the only way that we can define these things. We can always do that. It's just doing so would create drastic ripples throughout the rest of our formal systems that there's no, so far as we know, no good reason for doing that. But we can do it, is the point. So whereas in previous generations, the beginning of modern philosophy, and certainly in ancient philosophy, they accepted the notion that, these are necessarily true. Necessarily, not just here for us because they work pragmatically. They're true here and everywhere else in the universe, and nothing can ever show that they're false. Quine doesn't accept that, right? So that's an important bit. So conservatism is a virtue. But there will be occasions when we don't want our hypothesis to conserve, but all things being equal, we tend to privilege the hypothesis that doesn't require that we kick out a lot of the stuff that we had previously accepted to be the case. So that's the first virtue. The second virtue.
Second virtue is modesty.
All right.
And this is a policy which guides science as well as common sense. One hypothesis is more modest than another that is weaker in a logical sense, if it is implied by the other without implying it. And one hypothesis is more modest than the other if it is more humdrum, that's a more usual event and to be expected. So the example that I put in, there's a couple of good ones. This is more about using kind of the conservative method as well and saying that you should have a series of little leaps that make sense and you judge modestly rather than making one huge leap and ending up somewhere that doesn't make sense.
I think that's a nice layman's way of putting it, right?
I'm all layman.
Let me give you two possibilities. Of the two, which is the more modest hypothesis of what I give you here? Why is it more modest? It's simpler. We don't want to confuse modesty with simplicity, but there's some overlap here because that's its own virtue. The reason that A and B isn't as modest as A is because A and B implies A, whereas A doesn't imply A and B. So it's more modest. And all things being equal, it's a virtue when it's more modest than something more complicated, right? And I like the way that he puts it. He says it's weaker in the logical sense if it is implied by the other without implying it. So A is implied by A and B, but it isn't the same thing. So he says a hypothesis A is more modest than A and B as a joint hypothesis.
I also like the thing that says here, it tends to be the counsel of modesty that the lazy world is the likely world.
Right. Yeah, I like that. We are to assume as little activity as will suffice to account for appearances. You know, so don't make it more complicated than necessary. This is a little different than Occam's razor, which we'll mention here in a second. Keeping the assumptions down is a good thing. This is a policy, I like, as you just said, this is a policy that guides science as well as common sense. But this sort of overlaps with simplicity, so we need to turn our attention to the next version. So, we okay with modesty in the logical sense? So, don't assume more than you need to assume, right? Okay, what does simplicity?
Okay, virtue theory, simplicity. Most vivid, he talks about, you can really see it more in the graphs and curves and charts, but it has a place in any hypothesis. It favors the simplest hypothesis that works well in most cases, as we just talked about, A over A and B together will always be simpler. But sometimes you must sacrifice simplicity of a part for a greater simplicity of the whole. So he gets into a lot of very, very scientific examples here. I went with gravity. So the simple definition, heavy objects tend downwards. But when Newton went in and did a little more research, they found that there was magnetism coming from all forces surrounding, up, down, everywhere. So then, but his universal gravitation encompassed the simple act of the apple falling to the earth and more complicated calculation of the orbits of the planets into one single system.
All right.
So his overall system worked for the simpler system as well.
Can you tell me what Occam's razor is? Have you heard of Occam's razor before? All right. Did you ever see the movie Contact with Jodie Foster? And she makes reference to Occam's razor, quite often. What is Occam's razor?
It says that the hypothesis that's most reasonable to believe is the one that involves like the fewest assumptions.
Mm-hmm. Which sounds a lot like how we define modesty here. So you shouldn't assume more than you really need to. Make it modest. Why is that Occam's razor? I mean, what's the alternative?
Is that instead you could believe a hypothesis that makes all these like wild jumps, and then it's really not as reasonable to maintain because it's more likely to be not the case.
It doesn't have to be wild so much. What Occam actually said is that you shouldn't multiply entities beyond necessity. So what simplicity has to do with is all things being equal, the simpler hypothesis, or the one at whatever, is going to be that which commits you to the existence of fewer numbers of things. The more things you have to commit yourself to the existence of in order to make it work, the more complicated, the less simpler it is. And all things being equal, the simpler of two hypotheses is more likely to be the case. So think about the Ptolemaic conception of our planets versus the Copernican conception. The Ptolemaic conception, we have observations in both, but in order to account for what it is that we're observing, we have to commit ourselves to the existence of these little epicycles, and the movements of the bodies as they make their way around the Earth. Whereas the Copernican solution is a lot simpler. It doesn't commit us to the existence of these other things. So simplicity has to do with, and this is related to the Occam's razor bit, not committing yourself to the existence of more things than you need. Modesty has to do with, it's all things being equal, the more modest of two hypotheses is the virtue, right? Yeah.
So he also describes it as limiting liability, because he asks us, why should the subjectively simpler of the two hypotheses stand a better chance of predicting objective events? That this is too much to expect. So the virtue of simplicity is just that it limits liability when it comes to hypotheses.
Yeah.
Not that nature necessarily is simpler, just that our liability in making false judgments is limited through simplicity.
I think that's fair. I like this other quote here at the beginning of that next paragraph. It says, there is a premium on simplicity in any hypothesis, but the highest premium is on simplicity in the giant joint hypothesis that is science. So, again, we're going to run into some conflicts here among these virtues pretty quickly. It says, commonly a hypothesis A will count as simpler than A and B together, thus far simplicity and modesty coincide. But in what ways are they different? Can you think about that? Molly, do you have any thoughts about that?
I'm sorry.
There's a sense in which modesty and simplicity sort of overlap with one another, but there's a sense in which they don't. So he says, commonly, a hypothesis A will count as simpler than A and B together. Thus far, simplicity and modesty coincide, because he used that very example when he's talking about, well, the modest hypothesis is the A versus the A and B, the joint hypothesis. So, can you or anyone tell me in what way simplicity and modesty are different? Because we've got two names, two different virtues, but if if they mean the same thing, then we only need one virtue. So what's different about simplicity versus modesty?
Sometimes we have to be immodest when it comes to these sort of micro judgments in order to have sort of more of like a macro simplicity. So we have to be immodest on this individual level of hypotheses in order to make the web of belief strong when it comes to the macro.
Yeah, that's a nice way of putting it. Yeah.
Or I mean, like so you have A, B, and C, and D. Simplicity favors D, whereas modesty doesn't favor any of them.
Why?
Like, well, modesty would favor AB over ABC because it's implied without implying it.
A.
It wouldn't favor D.
A and B, A and B and C,
And then
A
D.
and B and D.
Well, no, just not A and B, just D separately on its own. It's a separate hypothesis.
All right, so what's D? Are you saying D is going to be?
Well, not A. I didn't have A. Just D, A and B, and A, B, and C. So D is the simplest of those. A and B is the most modest, right?
No, that would be the most modest.
Yeah. Well, it doesn't imply the other.
It doesn't,
Implied by it.
but it. I'm thinking there's going to be a Well, is it possible for A and B and C, and D to be consistent? Yeah, if you make them all true, it's possible.
Yeah, I'm just like so. A and B or A, B, and C implies A and B.
That's correct. So in that sense, A and B
Is
is
more
more
modest
modest
than A, B, and C.
and simpler than A, B, and C. Yes.
And I don't think that modesty applies to the difference between A and B and D. Like, it doesn't seem like modesty is there if it's talking about the implications.
So this would.
So D is simpler, but just modesty doesn't apply to that.
I would buy that. I would buy that. And in the logical sense, clearly this isn't applied by either of these, but it's in the abstract easy to imagine that D could be just completely different. It doesn't have anything to do.
Yeah.
So it may violate other things, but
Mhm.
okay, I buy that.
That's why modesty can be not simple on the individual level.
Right.
because, you might have to make these huge changes in order to affect a more stabilization when it comes to.
And again, these aren't necessary and sufficient conditions he's trying to identify in order for us to, that is, you ought to prefer this hypothesis if and only if this condition is met, this condition is met, this condition is met, and where these conditions are. It's conservative, it's modest, it's simpler because there are going to be some conflicts. Science is messy. What's that? Well, give it again.
I was going to say that.
Where are you?
Virtue for generality.
I think. Oh, so are we good with simplicity, folks? All right, then. Let me mention a couple things. He says, the longer the leap we reflected, the more wilder ways of going wrong. He says, simplicity, like conservatism and modesty, limits liability, is parodying something that James said. So, all right, generality.
All right, virtue for generality. Wider the range of application of a hypothesis, the more general it is. For example, going back to Newton's hypothesis of universal gravitation. And this section also gets into two kinds of hypotheses that are not really widely accepted in the scientific community. The ad hoc hypothesis.
All right.
And that is a hypothesis, any hypotheses that purport to account for some particular observations by supposing some very special forces to be at work in particular cases in hand and not generalizing sufficiently beyond those cases. These are useless in prediction and insusceptible of confirmation.
And bad. And
Yeah.
you've been hearing about this since, we started the semester, that people are persuaded by bad reasons all the time, right? So if you're doing science, you shouldn't be letting your personal biases sort of infect your interpretation of the data, right? Because you're probably not going to be doing good science. But here's the idea. If you have a hypothesis that you're committed to, or a theory, or whatever it is, and instead of letting the evidence contradict the hypothesis, show that it's wrong, you preserve the hypothesis by adding these additional assumptions that you need in order to make sure that we don't get rid of it. Like, I'll give you an example. In the 19th century, one of the luminaries in the history of neuroscience was Paul Broca. Right? Paul Broca did some really interesting lesion studies on his famous patient named Tam, because Tam had what's called an aphasia, a language disorder. But his disorder was one of production, not of comprehension. So it turns out Tam could only say Tam. So like Timmy. And when he died, yeah, right. When he died, they opened his skull and found this lesion, this area of damage in the frontal lobe of the brain, localized to the motor cortex, in an area that we now refer to as Broca's area. So this is a guy who's done good science. So we generalize on the basis of Tam and other people who had a language disorder like that, which we call Broca's aphasia, that region of the brain is responsible for the production of language. We have another kind of aphasia called Wernicke's aphasia, which is a language disorder of comprehension. And we discover its location by doing these kinds of lesion studies too. Point is, Broca believed that brain size corresponded to intelligence. And as a hypothesis, there's nothing unscientific about it or even pseudoscientific. But he had amassed quite a bit of data on, say, the brain size of people who had a reputation for intelligence, brains of women, brains of men, and he believed that men are more intelligent than women because their brains are larger than males' brains are larger than women's brains. And he attributed that to intelligence. But that's not the reason. He didn't let the evidence falsify his hypothesis. Why is it that male brains are larger than female brains on average?
Bigger things than females.
Bigger bodies have bigger brains.
Yeah.
So you take a look at an elephant, holy crap, that thing's big. And I think elephants are intelligent, but I don't think elephants are as intelligent as us. Again, intelligence is sort of relative, right? Depends on what you mean. But since we're the only creatures on the planet that have a language, and we do lots of wonderful things with language, language is special. It's related to knowledge and the limits of knowledge and whatnot. And I'm not saying that elephants don't know things. They do. Elephants, in fact, seem to be one of the few species on this planet that have a concept of death. And an awareness of when they come across the bones of another elephant that they knew, that there's a recognition there. The point is, if brain size corresponded to intelligence, then the biggest brains we have would have to be the most intelligent things.
Some really smart whales.
Some really smart whales, right? Here's the point. Instead of letting the evidence falsify his hypothesis, he preserves it by adding these additional ad hoc assumptions. And generally speaking, when the only way you can save your hypothesis is through the addition of these ad hoc assumptions, you're doing bad science. You're just not allowing it to be falsified. Another word for this is you're begging the question, right? So that's bad. So there are hypotheses and there are hypotheses. Ad hoc hypotheses are not good hypotheses. So generality, in like the way they begin, it says, the wider the range of application of a hypothesis, the more general it is. So you don't want a hypothesis that's only going to range over a small domain. You want it to range over as big a domain as possible. Otherwise, I mean, think about it. We could form a general rule or law based on observations of students in one particular class, but that doesn't mean it's a good generalization as we apply it to all students because the sample's so small. So we want our hypothesis to cover a wide range, or as wide a range as possible, rather than a really narrow range, all things being equal. But there's a problem with this, in that he says, virtues 1, 2, and 3 made for plausible. So does virtue 4 to some degree, we see, but that it is not the main claim. Indeed, generality conflicts with modesty, but generality is desirable in that it makes a hypothesis interesting and important, if true. Do you see how generality conflicts with modesty? Well, I've got one person nodding their head. I mean, these aren't necessary and sufficient conditions. He's not doing a conceptual analysis on what makes something a hypothesis or why it is that we should prefer one hypothesis over another. And there are going to be some conflicts between these virtues, right? And sometimes we're going to privilege one virtue more than another. But they're talking about the practice of science, and there's essentially these normative standards that we can apply to why does we end up preferring one hypothesis over another. So we want the general. It says, a generality without simplicity is cold comfort. And they talk specifically about the Michelson-Morley experiment. In 1887 is a case in point. The purpose of the delicate and ingenious experiment was to measure the speed with which light travels through the ether. In fact, can someone read the rest of that paragraph?
For 2 centuries from Newton onward, it had been a well-entrenched tenet that something other called the ether pervaded all of what we think of as empty space. The great physicist Lorentz had hypothesized that the ether itself was stationary. What the experiment revealed was that the method that was expected to enable measurement of the Earth's speed through the ether was totally inadequate to that task. Supplementary hypotheses multiplied in an attempt to explain the failure without seriously disrupting the accepted physics. Lorentz, in an effort to save the hypothesis of stationary ether, shifted to a new and more complicated set of formulas in his mathematical physics. Einstein soon cut through all this, propounding what is called the special theory of relativity.
And go on to the next paragraph.
This was a simplification of physical theory. Not that Einstein's theory is as simple as Newton's had been, but Newton's physics had been shown untenable by the Michelson-Morley experiment. The point is that Einstein's theory is simpler than Newton's, as corrected and supplemented and complicated by Lorentz and others. It was a glorious case of gaining simplicity at the sacrifice of conservatism, for the time-honored ether went by the board, and far older and more fundamental tenets went by the board too.
Quine likes to use that phrase, went by the board. We threw it out, the baby with the bathwater kind of thing. We could, as they attempted to do, maintain our commitment to the existence of ether, but it required more and more and more complicated formulas. And the beauty of the special theory of relativity is we just got rid of it. And it ends up making our ontology simpler. And all things being equal, the simpler, the theory that commits us to the existence of fewer number of things is more likely to be true, right? And I like that. I really like that quote. It was a glorious case of gaining simplicity at the sacrifice of conservatism, for a time-honored ether went by the board, and the far older and more fundamental tenets went by the board too. I like that. So on the next page, he says, but here conservatism operates. One is loath to revise extensively a well-established set of beliefs, especially a set so deeply entrenched as a basic portion of physics. And one is even more loath to abandon as spurious immense numbers of observation reports made by serious scientists. And that's true, right? We don't like to make revisions, and particularly when we would have to make revisions to the truth values of things from reports or observation reports by well-accepted scientists. But we can do it. All right. I'm just reading about the ad hoc here to see if anything we missed. Ad hoc hypotheses are hypotheses that purport to account for some particular observations by supposing some very special forces to be at work in that particular case at hand, and not to generalize insufficiently beyond those cases. The vice of an ad hoc hypothesis admits of degrees. So, insusceptibility of confirmation, uselessness in prediction, which ultimately leads to the fifth and final virtue, which is what?
Immutability.
All right. What is that?
All right, immutability is the degree to which a hypothesis partakes of this virtue is measured by the cost of retaining the hypothesis in the face of imaginable events. Conflicts of other beliefs may not arise. The greater the sacrifice, the more refutable the hypothesis. And another, great example is astrology, of course. Even if the prediction is wrong, a follower can justify it somewhere else, a planet they hadn't calculated properly, or some other good excuse.
Yep. It says, in fact, I really like that beginning of the paragraph. It says that these reflections bring to the fifth virtue, to the fourth, that is refutability. It seems faint praise of a hypothesis to call it refutable, But the point we have now seen is approximately this. Some imaginable event, recognizable if it occurs, must suffice to refute the hypothesis. Otherwise, the hypothesis predicts nothing, is confirmed by nothing, and confers upon us no earthly good beyond perhaps a mistaken peace of mind. I really like how he puts that. This is too simple a statement of the matter. He says, but just about any hypothesis, after all, can be held unrefuted no matter what by making enough adjustments in other beliefs, though sometimes doing this requires madness. This is another way of Quine, what is originally said. Any statement can be held true, come what may, if we make drastic enough changes elsewhere in our system. So we can hold anything to be true, provided that we're willing to add some ad hoc hypotheses in order to hold on to it, to immunize it from revision. But doing so in certain contexts, as I think I like how they put it here, would be madness, right? So, classic examples, astrology. So we say virtues 1 through 5 are guides to the framing of hypotheses that, besides conforming to past observations, may plausibly be expected to conform to future ones. Because that's what science is in the business of doing. It's telling us not just what exists, but enabling us to explain the past and to predict the future. He's talking about laws of physics and whatnot, and mathematics. All these laws, those of physics and those of mathematics equally, are among the component hypotheses that fit together to constitute our inclusive scientific theory of the world. I mean, he takes that metaphor of a web of belief, seriously. At the core, the center of the web, are going to be our truths of logic and mathematics and so on. And the farther away from the core will be, the things that we believe, based on, say, observation alone. But there isn't anything in this web, interrelated web of beliefs, where theories are, collections of statements, and we can't confirm or infirm our statements one by one, but only as a corporate body. It can be chunks of the web of belief. And we can hold on to the truth of any of them, but doing so may require drastic changes elsewhere. And we tend not to want to do that because we don't like adding ad hoc hypotheses just to preserve something. We want it to be conservative where possible, but these 5 virtues, there are some conflicts here, and well, that's okay. But we're going to be spending, starting today, a fair chunk of time for the remainder of the semester talking about how it is scientists come to accept one theory or hypothesis over another. This will be particularly the case when we get to Quine and his revolutionary kind of approach as opposed to the evolutionary approach. In any event, what else do we need to say about these 5 virtues?
Well, in summary, I have virtues 1 through 5 are here to frame a hypothesis, but the heart of the matter really lies in observation.
Which we were talking about last class and the class before that. If Hansen's right, then observation is theory-laden. It's an automatic process based on past experience. So there's a sense in which you and I, or a layman or a child, we're all looking at something that visually speaking, we're seeing the same thing, but there's a sense in which we're not seeing the same thing. And it's not because you're seeing it and then reflecting on it and interpreting it. Rather, it's just you see it as whatever it is based on your past experience, whatever theory you accept. So Kepler and Brahe, observing a sunrise, say, are having, all things being equal, the same visual experience, but what they're seeing is different, right? The scientist, the layman, and the child looking at the X-ray tube are going to be seeing something different. This calls into question the neutrality of scientists when they're making their observations and reporting what it is that they're observing. Because, science is supposed to, be what's based on hypothesis testing, which requires observation, which requires reporting what it is that you're observing. But if what the scientist sees is something radically different from what you or I see, then, is the world as it appears to us? Is an interesting question, because as it appears to us, from the standpoint of the scientist, from the standpoint of the layman, because we're not seeing the same thing. But it was also related to the issue of how does observation play a role in determining the existence of those objects that we can't observe, like the theoretical entities, the submicroscopic particles. And we did that in the context of the realism, anti-realism debate. So the question is, do submicroscopic particles exist in the same way that, well, do orange shirts and sodas and whatnot exist? Well, we can observe those. We can't observe the other. So a realist would say, yes, they do exist. The anti-realist would say, no, they don't. And it doesn't correspond to anything even close to observation. But there's a middle way, that pragmatic way that Stace and Tolman both defend, which is, well, maybe they do, maybe they don't. But if they're useful theoretical fictions that enable us to explain how things are and to predict how things are going to be in the future, recognizing that all science is revisable, then sure, they exist. When they no longer become useful, either as an aid to explanation or prediction, then we eliminate our commitment to them. So you can, it's not, the realism, anti-realism debate isn't necessarily one or the other. They take sort of a middle path to it. But that's related to this, because you can't do science without hypotheses, and you can't do science without testing. You can't do that without observation. So this is a short piece. And I don't think this is a terribly contentious or controversial thing that they're defending here, because they're not identifying necessary and sufficient conditions, because you really can't do that. So I always risk getting the answer that I know I'm going to get when I ask this question. Do you have anything you'd like to add to the discussion about the Quine and Ullian piece? As I'm hearing the congestion and the nasal tone of my voice, the more I'm speaking. Anything else you want to say about this? What? Don't do that.
I mean, they're on the board.
Yeah.
Okay, so the second thing I have is accepted hypothesis must conform to past beliefs and future ones as well, and may be opened up to new scientific questioning if they cannot. Hypotheses serve two purposes: to explain the past and conditionally predict the future.
That's what we were just talking about. Yep.
And we inherit the main hypothesis: there are civilizations' continuity of beliefs.
And that's the importance of conservatism. So all things being equal, like my invisible pink fairy theory isn't very conservative. Commits us to the existence of more things than our ontology commits us to the existence of. So it wouldn't exhibit the virtues that would make us want to privilege it versus a competing hypothesis. You can come up with lots of examples like that. All right, I have already posted a 1-minute argument question for Quine and Ullian. I posted a question about observation related to the last couple of classes. So answer that one. I'm not letting you